Alright, so I just quickly here want to go through a couple examples on how to model law of sines and law of cosines, and then I want you to try some. We will have our CFA next week over this, and then quickly after that our test. So remember, law of sines is sine of an angle over the corresponding side. So that side is opposite of the angle, and that's equal to the sine of different angle over the side length. Okay? And then you can set up the third ratio, set it equal to that, but really we just want two pairs. So for this first example, we have Anagelo, I don't even know how to pronounce that, needs to draw a triangle for her geometry class. So triangle. She makes one angle 68 degrees and another angle measuring 48. It does not say where, it does not say it has to be in a certain spot. So I just need to make one of these 68 degrees, notice angle, and then another angle 48. With the side opposite that angle, so the 48 degrees, the side opposite of the 48 degrees, opposite, does not touch it, is 32 millimeters. What would the length of the side across from the 68 degree angle be? So across from, the 68 degree angle would be what we're trying to solve for. Remember, with law of sines, you're looking for an angle, the side opposite, and then at least another angle. And then solving for the side opposite of that angle. So we are going to set this up. Sine of, and pick one of your angles, 48 degrees, over the side opposite. In here we are told the side opposite is 32. Then we set that equal to the sine of the other angle and divide it by the side opposite of that. And then if you recall solving for law of sines, we cross multiply, so x times sine of 48 is equal to 32 sine of 68 degrees. Divide both sides by sine of 48. Because remember, we want to undo that multiplication, and we should get x equals give you a moment to type it in your calculator. It will be about 40 degrees. Not 40 degrees, wow, that's not an angle, about 40. I had 39.9, so if you want to round to the 10th, that's fine. Excuse me. Which makes sense, since 68 degrees is larger than 48 degrees, that side length should be a little bit bigger. Okay. Moving on to the next one. Pause it if you need to go over anything again. Let me know if you have questions. The next one I do want you to try, so I would pause it either way. Try it and then come back to this. So take a moment to do that. Alright, so we know we have a triangle. Draw it however you want. And we know two angles are 25 degrees and 57. The shortest side is 15 meters. So I have to remember this is across from the smallest angle. So I take that 180, subtract out the two I know just to make sure that I've got the smallest angle, and that third angle is 98 degrees. So 180 subtracted by 25 minus 57 gives me that 98. So the shortest side is across from the smallest angle. Across from 25, that is the 15 meters. Another reason why I wanted to check what is that third angle is because I need to find the longest side. And the longest side is across from the longest angle, or the largest angle. So I looked, 25 is the smallest, then 57, then 98. So I'm solving that side opposite. Which means I'm taking the sine of one of my angles over the side opposite. So in this case, sine of 25 over 15 is equal to the sine of 98 over the side length I'm solving for. Then to solve for x, we cross multiply x times sine of 25 equals 15 times sine of 98. Divide both sides by sine of 25. And I need to put that 15 sine of 98 divided by sine of 25 in my calculator. And I get 35.1 meters. Which makes sense because that is much bigger than the original side I knew. Over twice as much, which is the 98 degrees, twice as big, over twice as big as the 25 degrees. Okay. I just want to help you set up 2 more problems. So if you go to your the very last page in your notes, page 16, in that, I believe it's purple packet, green packet, you find this one. So pause it if you need to, but all the way at the top of the page, you've got example 6 and example 7. I just want to help you set up the triangle and then tell you what the answer is. I will have the answer. Remember, the answer key is already, or this key for my notes is already on Schoology. But I think the only difference between this and what the first part of the CFA was over is just being able to draw the picture. Okay. So in example 6, we have a triangle. We have a triangle with side lengths 10 centimeters, 9, and 3. It does not matter where you place them. We want to find the largest angle, which is across the largest, across from the largest side. So 10, 9, and 3. 10 is the largest side, which means that across from it, this angle right here, that's the angle I'm solving for. So that's my angle. 10 is across from it, so you can set it up. 10 squared equals, and let me back up, when I'm given all 3 sides, so I have all 3 sides, this is when we use log. So 10 squared equals 9 squared plus 3 squared minus 2 times 9 times 3 is cosine of x. Go through and solve that, and in the end you should get x equals 79.3 degrees. Take some time, solve that, pause it, come back for example 7. Example 7, from point C, both ends A and B of a proposed railroad tunnel are visible. A, B, imagine there's a tunnel here, and then somewhere over here at point C and see them both. So a person standing here at C is 165 meters away from A, so 165, and is also 115 meters away from B. The angle made between both viewpoints at C is 74. So from C, I'm saying at C, that angle there to look at A and B, so right here is 74. And we want to find the length of the tunnel. So remember, the length of the tunnel, if I go back to the first sentence, is from A to B. So this is the length I'm solving for right here, little c. from there, I think I have two sides and the angle in between, so that would be side and side. And if you recall, you're going to use law of cosines. So I know angle C, so I'm for side length C, so that arrow points to the side that's all by itself on the left side. So C squared equals, then it doesn't matter the other side lengths, 165 squared, 15 squared, minus 2 times those two side lengths, times the cosine of the angle I know that I'm going for that's across from the side length C. And this one is nice because all I have to do is square root both sides and stick that in my calculator. So don't forget this one here. And in the end, you should get 173.2 meters. So please take your time, put in the calculator, work on that. After this, for a second, check that. But once you finish these examples, I do want you to work on that yellow worksheet that was attached to your law of sines modeling notes. Okay? Try to do those over the weekend, and we will review them on Monday.